Hey, hi guys, welcome to the channel. Hope you are doing well. So today in this video, we will code all the three solution approach that we had discussed in the last video about Sherlock and Anagrams problem on HackerRank, and then we'll make the submission and see which all the approaches or which all of the three solutions, which among the three solutions are passing all the test cases. Okay, so let's begin with the solution. So here we have given the function Sherlock Anagrams. In this function, we have to solve the question. We have to write the codes to solve this problem. So first we have to, let's say we have a given string s here. We have a given string s. So let's first take the length of string, and on the basis of this, we have to iterate through all the loops. Okay. Yeah. So we have the length of string, and then if you remember the first approach that we had, right? What we had, so we had to iterate through two loops in order to find all the possible substrings. So let's iterate through for I in range 0 to n and I plus 1 I plus 1 n plus 1. Okay. So let's say we have a string ABC. So once we have our first pointer at A, right? In order to take this particular one character substring A, we have to give the index from S of 0 to 1. 1 is exclusive. Okay, in Python, this 1 is exclusive. So only the first character will be fetched. When the J pointer is at C, J pointer is at I plus 1. When I will be 0 and J pointer increases by 1 more, so J will become 2. Now if you put 2 here, now the substring you will get is A and B. Those characters situated at index 0 and index 1, but 2 is exclusive. Okay, that's why we have taken I plus 1 till n plus 1. Okay, all right. So let's start with next step. So let's make a list which contains all the substrings list. We have this, and then we will append all the substrings over here. Substrings dot append s of I to j. All right. So we have got all the possible substrings from this. So why is this here? Okay, this will not be space. Right. So we have got all the possible substrings. After this, we will get all the length of all the possible substrings. That is what is the total number of substrings that we have. Okay. Now, I think we are getting this range for I in range y. Yeah, so now there is no error. So we have got the length, total number of substrings in the substring list. Now we will iterate through the length of substring for I in range. Okay, 0 to m, that is length of total number of substrings, and then for j in range starting from I. Because in this case, if you have, I will show you an example. Let's say you have A, and A, here. Then if you start with this, your I is here, okay, then J will be here. Actually, no, it should be also I plus 1, actually, not I plus 1. Otherwise, you will get a blank value as a pair, okay? So let's start I plus 1 until M plus 1, okay? I was wrong here, it should be I plus 1. So now we have two loops and we want to check, let's say, if I is not equal to J. For the condition when I is not equal to J, we want to check if sorted of substrings of I, okay, whenever I is not equal to 0, sorted of substrings of I, that is the substring located at particular index I, should be equal to, we are checking if they are anagrams or not. The substring located at index I and the substring located at index J, we are checking here only if they are anagrams to each other or not. If we sort both of the substring, are they exactly same or not? Okay, that is what we are checking. Sorted substrings of J Okay, if this is the case, they are anagrams, we will say anagrams pair dot pin. Okay, and inside this we have substring of I and substring of G. Okay, we need to define anagrams pair as a list, anagrams pair as a list. Okay, now we have stored all the all the possible anagrammatic pair, okay, will be in this what you say particular list. Okay, one thing I have missed, I think. So since there won't be a case of I equal to J, right? If I is 0, J will start from the next index, that is 1. So there will not be any case of I not equal to J. We can remove that case. I think earlier I had only I. Okay? Earlier I said only I will be there. That's why I think I had kept that not equal to J. Not equal to I is not equal to J. All right. Now we have all the possible anagrammatic pairs in this list. Now what we need is we have to just return the length of this anagrammatic pair. That's what this was the first approach that we had discussed yesterday, okay, in the last video. So let's try running this solution and see if we are able to pass the some test cases. We run this code. We have an error. What is that error? List index out of range. Okay. So if m plus 1, then substring of J, this will be obviously out of range. Let's do it m. It should be m. Now let's try running this. Yeah, we have passed all the sample test cases here. So now let's try submit the code and see if we are able to run all the test cases. All right, guys. So if you see here, we have passed these 3 test cases, but we have terminated due to timeout these 4 test cases. So our approach is not wrong. Answer we are not getting wrong. We are timed out while calculating all the possible answers. Okay. So as discussed yesterday, the time complexity of this solution is O of n cube log n. Okay. So we have issue with time complexity over here. The code is terminating due to timeout. So let's try the second approach that we had discussed. Even that was O of n cube log n. But at least let's try if we are if our solution is working or not. The second approach code is working or not. Let's try that. We'll just try and make the submission if it works or not. So let's say we have again yes, this was the second approach that we had discussed, length, and then we can have anagrammatic pair dictionary, anagrams pair, where we will store all the possible substrings and possible sorted substrings and the count of each substrings. If you remember, we had found some pattern of storing the count of substring. If you haven't watched my last video, please go through that. Okay, and then you will be able to get the solution here. So we have in order to find the substring, we need obviously 2 loops for I in range n, and then for J in range it will be I plus 1 to n plus. Okay. Now if join sorted s of I to J. Okay, so when you sort this string, right, this particular string will be converted into a list. Okay, so for that, to make it again a list, again a string, we have used this join statement. We are joining all the possible character of the list with blank value. Okay, and now if we will check if this value in anagrammatic pair, in anagrams pair, if this is there, then we will simply increase for this particular substring, if it is there in anagram in the list in the dictionary anagrammatic pair, we will simply increase the counter by 1. If not, if it is not there, we will add this substring in the dictionary and assign the counter as 1. Okay, so we have now a dictionary where the count of each substring is available over. Now the next thing is to check the count of all the substring and see how many possible anagrammatic pairs can be formed. Okay, so we have for key comma value in the dictionary anagrams pair dot items. Okay, now first let's have a value variable anagrams pair count. Okay, initialize this with 0. Now we have if value, let's say if the value is equal to 2, what was the count of anagrammatic pairs that we would get if there were only two substrings, I mean two occurrence of a substring in the all the list of substrings? The value would be 1. Anagrammatic pair count. It's pair count. Okay. Anagrams pair count. Then we will have anagrammatic pair count increased by 1. If the value of count of substring is only 1, then would anagrams pair count increase? No. So we will not increase anagrams count here. We will simply continue. Else now we will have as count is equal to 0, a new variable in the else part, and for all the possible range value of that particular value, that is the count, for I in range, okay, this value, what we had to do, we had to sum up all the possible value before all the numbers before the count, the actual count of substrings. Okay, and then we would increase the anagrams pair count with the variable with the number we have stored in the value count in else statement. Okay, so this was the second approach that we had discussed. Now let's return anagrams pair count. Okay, so this is the second approach of solution that we had discussed. Let's run the code. We have an error. We have an error. So in order to check what exactly the output we are getting, let's run it in one of our local editor. I have Jupyter Notebook. So here we have this now anagrammatic count, pair count is increasing. So let's check what all values are there in anagrams pair. So the substring question we are passing to we have A2, AB count of AB is 2, ABB is 2, B2, BB is 1. Now why are we getting the count of anagrams pair count as 0? If key comma value for key comma, sorry, it's not right, it's pair. That is right. Value is equal to anagrams pair count is. So let's check debug here. Print key comma anagrams pair what we are getting from. Okay, and then after this, what are we doing? syntax over here. Syntax here. Outside. Yeah. So value is equal to 2 for key A. The value is 2. It is 0. Anagrams player count. Sorry. It's a small mistake here. It should be this. Yeah, it should work. Yeah. So it's working. There is a simple mistake, simple thing that I have missed here. It's, right. Now it's done. We still have one error. Okay, let's debug this part. We have your output 3 and 8. Expected output 3 and 10. So it didn't work for this part. So let's go to the group again and see what it is coming. We have K as 3, K as 2. So here we will have 6. Here we should have 6, 3 to 5, and then 6. Count is equal to count plus 1. It should be 6 over here. This is wrong, and then plus 7. We should get 6 for this, since the count is 4 of A. For I in range value and the value count 0, 1, 2, 3, 3 to 5. We'll start with 0. Sorry guys, it is so count is 2. Now if we see what is count for, so where is getting 4? Sorry, this should not be 1, it should be I. Sorry guys, there is a simple mistake once again. So here it should be, instead of 1, it should be actually I. We have to sum all the numbers before the count of substring. Okay, so count plus I. Now it should pass all the sample test cases. Yeah, we have passed all the sample test case. Now let's submit the code. All right, guys. So here, if you see, we have passed all the test cases. Okay. For this case, we have passed all the test cases. Now, can you think why in the first case where the time complexity was n to the power 3n cube log n, okay, and in the second case also we have time complexity as O of n cube log n. So why did it pass in the second case but not in the first case? Can you think on it? Can you think on it, guys? So let's discuss one thing. I think I did a mistake yesterday in calculating time complexity. Okay, so this is n cube log n. You can see O of n square, O of n square for 2 for loops, and sorted O of n log n. So O of n cube log n we have, that is the worst case time complexity. Okay, in this dictionary we will have substrings less than n. So we can consider this as O of n case. So the time complexity for this part is O of n. So worst case we have time complexity of O of n cube log n. However, in the earlier case, if we go to earlier case, okay, so let's go to the submission actually. We will see the earlier case where we got it. So this was the earlier case. In the earlier case, if we check Okay, so here we have time complexity of not here, actually here. So here we have time complexity of O of n square, correct? N is your length of string. Now here we have time complexity of O of m square log n. Sorry, O of m square, and then sorted is n log n. So we have over all time complexity of m square n log n, because length of substring at the worst case will be n. So sorting would take n log n, and here we have O of m square. Okay, and if you see here, what is the value of m? Value of m is nothing but length of substrings. And how many values will be there in substrings? Since we are doing this O of n square times, so there will be total of a total of n square number of substrings in this list. Okay, so if there are n square number of substrings in this list, and m value is here time complexity is O of m square, so we can replace m with n square. In this case, you will get n to the power 4 order of time complexity, 4 and above. That was the reason this particular code failed actually. In our case, O of n cube log n test case is passing. I mean, solution of O of n cube log n is passing successfully. Okay, all right. We have passed the second approach. Now we had discussed another approach, that is approach number 3, where we had used the the ordinance value. We had converted each character into its integer value, and then counted the occurrence of each string and each characters in each in each substring, and then did that particular solution. So let's start with that. But before looking at my solution, I would recommend you to try it by yourself first. Okay, the last approach, try it by yourself first, and then come back to check the solution if you are unable to solve it. Okay. Okay, guys. Okay, so let's start what we had discussed in the last solution. We have length of string as n. We had maintained a frequency map, if you remember, frequency map as a dictionary. Okay, and and for I in range n, okay, we had created a frequency counter. This is your frequency counter, where you will count the frequency of each character or each letter, you can say. So we have 26 letters in English alphabet. So we have initiated all the letters, count of all the letters with 0 initially. Now for j in range, it will be from I to n. Okay, and we will check if this particular character, that is s of j, between a to j. First we will check that a to j. If this is the case, what we will do? In frequency map, in frequency counter first, we will, for this character at jth position, we'll find the exact index for this. So it will be ordinance of, and we will subtract the ordinance of a. And at this particular index in frequency counter list, we will increase the count by 1. Okay. So since this is a case, we are always given a string which will contain only the English alphabets. So we have this case only. If there had been a case where it might be possible that there would not be English alphabet character, then we could have raised some error, and some error kind of case, we could have handled the error. Okay. All right, guys. So now we are getting error here. Okay, so this now once we have this, we will convert frequency into frequency table. Sorry, tuple. If you remember, I had asked a question via frequency. Okay. Now we will count the occurrence. Count occurrences of this frequency tuple. How many times this tuple is occurring? Okay, we'll count this. So if frequency table, sorry, you can say frequency, yeah, frequency table, you can say frequency table in frequency map. If this is there in frequency map, then we can, what we can do, we can simply increase the value of counter, right? Frequency map, okay, the frequency map, and then frequency tuple, that is table, we will increase the counter by 1. If this is not there, we will insert it. Frequency map, frequency table, assign this counter as. Now we have a dictionary where count of each substring is available. Now we can use the same approach of earlier, that is for the comma value frequency map, okay. If the value is, the count is equal to 1, then we will continue. We will increase the anagram pair count. So let's see, have a variable anagram pair count is equal to 0. Now we have syntax error. If value is equal to 2, then we increase the anagrammatic pair count by 1. Else we have a variable count equal to 0. And for I in range, the value of the all the possible value, the count substring, we simply count, increase the count by I. Okay. Now we can increase the anagrammatic pairs count by the value of count over here. Okay. Now return anagrammatic pair count. Let's run the test cases. And there is some issue about that. We have some issue. What is this? Okay, and this is we still have too many values to unpack, so this will be bad. We have passed all the test cases. Okay, now let's submit. All right, guys, you can see we have passed all the test cases and got congratulations. Okay, so that's all for this video. In this video, we have seen 3 different approaches to solve the problem Sherlock and anagrams. Okay, that's all for this video. Thank you.